All right, so similarities. Similarity. Okay, when you say two shapes are similar, what does it mean? It means the two shapes are same in, the two shapes, okay, they're same in shape, not in size. The shape is same, but size can be different. So these squares are always similar because there's no other way to draw a square. So the shape is always same and their size can be different. Two triangles are similar if they are exactly the same. For example, these two are equilateral triangles. So they are same. Okay. Now for two triangles, we are talking about triangles here. For two triangles to be similar, what all has to be same? Okay. So this is triangle. This is another triangle. ABC, XYZ. Okay, for these two triangles ABC and XYZ to be same, what all should be same is all their angles should be exactly same. For example, angle A should be equal to angle X, angle B should be equal to Y, and angle C should be equal to Z. If these three angles are same, uh, the triangles are similar. Okay. Now, how are the sides related to each other? How is AB related to XY? Will AB and XY be equal? They won't be.
AB upon XY.
Yeah, they'll be proportional to each other. Okay. So we'll see what is proportional. Now, AB and XY are called corresponding sides. Angle A and angle X are called corresponding angles. Corresponding means matching. Okay. So which is the side corresponding to AC?
XZ.
Which is the side corresponding to BC? YZ. Okay.
YZ.
Like these corresponding sides will not be equal, but they'll be proportional. Now, proportional means if I write corresponding sides like this, AB upon XY, that will be equal to the next set of corresponding sides, that is BC upon YZ. And it will also be equal to the next set of corresponding sides, that is AC upon XZ. This is the meaning of corresponding sides are proportional. Okay, so that's all. So I'll say that once again, if two triangles are similar, their angles or the corresponding angles will be equal and the corresponding sides will be proportional. Corresponding angles will be equal and corresponding sides will be proportional. Okay, that is the rule. Now there are there are a few rules or few conditions to check if two triangles are similar. The SAS, the AAA or AAA, and SSS. So there are three conditions. SAS, what does it mean? Side, angle, side. That means you have a side, say this side, this angle, and this side. It has to be in that order. Okay. So the sides should be proportional and the angle in between the sides should be equal. Okay. For example, AB upon XY should be equal to BC upon YZ. That's the meaning of the two sides are proportional. And the angle, that is this angle B, should be equal to angle Y. So if you have these three things equal or proportional to each other, then the two triangles are similar. The next condition is AA or AAA. Means two angles should be equal. If two angles are equal, automatically third angle also will be equal. So you're having this property, either two angles or three angles, the same property. We're not talking about sides in this theorem, in this condition. Just the angles. If the angles are equal, triangles are similar. We don't need to check the sides. Means sides will automatically be proportional. We're just proving that these two angles are equal. And the last one is SSS. That means all the three sides should be like this, proportional to each other. If they're proportional, then the two triangles are similar. Okay. So if you prove any one of these three, then the triangles are similar. Yeah. Totally, how many parts are there? There are 6 parts. 6 parts means 3 angles, and 3 sides. There are totally 6 parts. But out of the six parts, you don't have to show all six parts are equal or proportional. You only have to show one, two, three parts, or one, two parts, or one, two, three parts. You show this. If you prove these three things, or these two, or these three, the triangles are proportional. Sorry, yeah, the triangles are proportional. Now you have some properties of angles, parallel lines. All those things also can be used over here, like vertically opposite angles. Okay. Let me show you some properties. Mm, Okay, if you know this property, if you have two intersecting lines, then these two angles are called
Vertical opposite angle.
opposite angles, and they will be equal. Then if you have two parallel lines like this, and then you have a line that goes like this, then that's a transversal, right? So then you have more laws like these two angles. They're called alternate interior angles. Alternate interior angles. They will be equal. Okay, suppose I draw a line like this. So now I get two triangles. Okay. If I want to prove these two triangles are um, similar, I need to use one. I need to show one of these three conditions, right? So one we can show is that these two angles are equal. Okay, we got one angle. Then these two angles here, they are equal because they are vertically opposite. We got two, right? So by A, we can show that they are similar. We can also show the third one. This angle here will be equal to this angle here. Again, alternate interior. Okay, so we can prove all three angles are equal to each other when we have such a diagram. Or this diagram here, if I make this into two triangles. Now here we can only show these two angles over here are vertically opposite. You can't show anything else because these two lines are not parallel to each other. So we don't have those alternate interior angles equal. Okay. Is this enough to show that the two triangles are similar? No, it's only one angle, one set of angles. We need something else. So probably we need this because here there's one angle and two sides. So they must have given, this side should be equal to this side and this side should be equal to this side. If you have this much, then we have side, angle, side. We can prove that the triangles are similar. Okay. So like this, you need to find some way to prove that two triangles are similar by using any of these three conditions.
In that example, why can't we use alternate interior angles?
Because these lines were not parallel to each other. Alternate interior angles are equal only if you have parallel sides, parallel lines.
Yeah.
And so corresponding angles, what is that? Corresponding angles.
All these rules, corresponding, alternate interior, co-interior, they all are equal, or those rules work only if you have parallel lines. Okay. See, if I have two parallel lines like this, and then I draw a line like this, which is called a transversal, then I can apply those rules. Like for example, these two are co-interior angles. They add up to 180. These two are no, sorry, they're alternate interior angles which are equal, and these two are corresponding angles which are also equal. See, all these work only if these two lines are parallel to each other. If the two lines are not parallel and I draw a transversal, okay, we still call them co-interior. These two are still corresponding, and these two are still alternate interior, but they don't follow those properties. Like they're not equal, they don't add up to 180 or anything. Okay? Let's do this question number 12. Before that, just write on this.
And now for vertically opposite angles, there's no need for the lines to be
Don't you
parallel, right?
have
For the vertical opposite angles, the lines are not supposed to be parallel, right?
No, it doesn't have anything to do with parallel. That's why I did this before I drew these lines itself. We just need two intersecting lines. If we just have this much, they are vertically opposite.
Okay.
Okay, shall we see this 12th question?
Yes, sir.
Now, they will not mention which triangle to look at. You have to figure out which two triangles you're going to see. And yeah, so if the diagram looks too complicated, then you draw both the triangles that you need separately. Okay. Right. So given in this figure, you have angle GHE is 90 and DFE is also 90. And DH, okay, let me put it together. Now if you draw the diagram, okay. So they have given the lengths. There's no units for it. It's just the numbers. So DH is 8, DF 12, DG and DE 4x plus 2. Find the length of DG. Okay, so we have to find what is this 3x minus 1 and DE. This 4x plus 2. Okay. Okay, so 4x plus 2, that is part of which triangle? 4x plus 2 is this full thing, DE, and DE is part of which triangle? DEF. And this 3x minus 1, that is DG, is part of this triangle here, DHG. Okay. So you can draw both the triangles separately. Okay. Just draw them separately. That way you can write separate values for each, but keep looking at both the diagrams. So this is put the values in there. Did anyone try solving it? Okay, so what are the values that we have? This is 4x plus 2. DF is 12. And DH is 8. And GD is 3x minus 1. Right? These are the values that we have. Okay. Now, first of all, you need to show that the two triangles are similar. How can you prove that the two triangles are similar? What all do we have?
Angle H is equal to angle F by 90 degree.
Angle H and angle F are 90 degrees. So they're equal. So first we write the two triangles that we are going to compare. For triangle DGH and triangle DEF.
DEF.
So first, what was that? Angle H. Write the full name. That is GHD. Angle GHD is equal to angle DFE, which is equal to 90 degree. That's one. Next, anything else is equal? Any other angle? What about angle D? See, angle D is common.
Angle D is equal common for both triangles.
Yeah, so this D and this D both will be same, right? Because it's the same angle. So angle D for this triangle and angle D for this triangle is equal. Okay, so angle D is equal to angle D. The reason is common. You have to write reason for everything. Even for this 90, write 90 degree in a bracket. So that's the reason. Instead of writing equal to, you can write like this. Or given. Okay, given equal to 90 degree. All right, so we got two angles. We can't prove the third angle. Third angle is what? G and E. There's no way to prove that because it's not given and we don't need to. We got the two triangles. So by A condition, what? Triangle DGH is similar. This is a symbol for similar. Similar to triangle DEF. Okay. Now, since the two triangles are similar, all the angles are equal to each other, which means G also will be equal to E, and all the corresponding sides will be proportional to each other. Okay. That property, like when you prove that two triangles are similar, all the other things also are equal and or proportional to each other. That property is called what? What?
Basic proportionality theorem.
No. CPCT, something like that is no? Corresponding parts of congruent, not congruent, similar triangle. CPS, is it CPST? Corresponding parts of similar triangles.
CPCTC.
CPCT. CT is congruent triangles. This is not congruent. This is similar, no? Yeah, corresponding sides of similar triangles. CS, corresponding sides of similar triangles. Okay, they don't write it as an abbreviation. Okay, so we have to just write that statement. Okay. See, by A condition, this triangle is similar to this triangle. Therefore, corresponding parts. What is the meaning of corresponding parts? All the three matching angles and the three matching sides. They are corresponding parts. So these corresponding parts of similar triangles, we won't write parts because parts include angles and sides. Angles are equal, sides are proportional. So we'll just talk about the sides. So corresponding sides of similar triangles are proportional. Right, all the sides are proportional. So we can write that statement now. That is, all the three sides are proportional. GD, which is a corresponding side to GD? ED. Because they are the hypotenuse. Right, see, this is the hypotenuse of this triangle. Also hypotenuse. So those two are corresponding. Next, DH, which is a corresponding side to DH. Huh? See, it's between 90 degree and this known angle D. So here also this between the 90 and the known angle D is this DF. And the third set of corresponding sides is the unknown one, which we don't have. So here it is GH.
GH upon EF.
Here it is EF. Okay, so we have all the three corresponding sides, three sets of corresponding sides. Now, what do we need? We need to find what? ED and GD. And we have DH and FD. So we use only the required sides. We don't use that missing value. We don't need. So taking required fractions. Which are the required fractions from this? This one and this one. These two. We don't need this. So we write the required fractions and then substitute all the values in that. Okay. So GD upon ED is equal to DH upon DF. In that we'll substitute all the values. GD is how much? 3x minus 1. ED 4x plus 2 equal to DH 8 and DF 12. Okay. So now we get an equation, linear equation. Solve the equation, you'll get x. Once you get x, substitute x in this, you'll find ED. Substitute x in this, you'll find GD. Okay. All right, this is one moderate type of question that can come from similarity. These are the steps you're supposed to exactly follow. These are everything that you need to write down. This is how you solve it. Complete it and tell me the answer. Okay, so what are the steps that we have to follow? You draw the original diagram that's given, but then it's very useful to draw both the triangles that you're going to compare separately. Okay, then you can see each side separately, each part separate, it won't confuse you. Okay. Then you show that the two triangles are similar by using any one of the properties. So here we use the AA condition, show that the two triangles are similar. Once the two triangles are similar, all the corresponding sides are proportional. Therefore, we can write this property and then we can use the required sides and find whatever needs to be. Okay. Uh, we will look at the next question, but we won't solve it. We'll just explain. There are so many questions here and they get really tough also. Okay, we'll just do whatever is understandable. Hope a easy one comes in the exam. Okay. But in this two triangles, in the right angle triangle, QPR, QPR. Okay, so the full triangle, it's a right angle triangle. Okay, 90 over here. PM is the altitude. Okay, altitude means it's a line that's perpendicular to the base. That is altitude. Okay, so we have two 90 degrees here. For the full triangle, we have a 90 degree. And here we have a 90, which means these two smaller triangles also have 90 degrees on both sides. Okay. Given that QR, the full thing is 8 centimeter, and MQ, the small one is 3.5. Calculate the value of PR. PR. So you have to first ask yourself, now the values that are given and the values that you have to find are part of which triangles? Now, how many triangles are in this diagram? There are three triangles.
Two triangles.
Three
Two
triangles.
triangles similar.
The full triangle, that's one big triangle. Then the left side small one here and the right side small one here. So there are totally three triangles. Okay. So now which two triangles you're going to compare is what you have to figure out. So look at what.
Triangle PQR and triangle PMR.
So PQR, the full triangle we'll use because 8 centimeter is part of that. And even the PR that you have to find is part of that. And the small triangle, which one should you use? The right side or the left side?
Right side.
Okay, someone said left, someone said right. Now left has 3.5, but it doesn't have PR, which we need to find. The right side has PR, but it doesn't have any other side. Is that true? No. You can find MR, right? Because 3.5 and 8, you can find MR. So which two triangles we're using is a big triangle and right or left? Right.
Right.
So we have MR and we are finding PR. Okay, so you need to have at least two sides from both the triangles that you have to compare. Same like this one that we did over here. Okay, so like that, draw both these triangles separately. And what all are equal for both now? One is the 90 for the big triangle and 90 for this. So that's two things that are equal. What else is equal? Angle R. It's common for both. The big triangle and the right side triangle also has angle R. So we got two angles. So similar to this, we can solve this. Is that clear how to do it?
Yes, sir.
Okay. We'll go to the next part of this chapter, that is basic proportionality theorem. Basic proportionality theorem is when you have two similar triangles again, where one triangle is inside the other triangle. The base is parallel to each other. Okay, so suppose this is A, B, C, and D, E. Okay. So the small triangle ADE and the big triangle ABC. First of all, are they similar? How can you prove that they are similar? So if I'm drawing both separately, okay, what is equal to what? This is A, D, E. This is A, B, C. Okay.
Angle D is equal to angle B.
D is equal to angle B. Okay, D is equal to angle B. Because in this, see, they are corresponding sides, corresponding angles. Same way, angle E is equal to angle C. So E.
Angle A is equal to angle A.
Angle A is common for both. So angle A from here is equal to angle A over here. So we proved that all three angles are equal. Okay. So when we are doing basic proportionality theorem, we don't need to prove that the two triangles are similar. We just write BPT, basic proportionality theorem. Okay. And what does basic proportionality theorem state? That AD upon, what is that? Yeah, AD upon DB is equal to AE upon EC. Okay. let's write both the theorems, the laws of similarity and also basic proportionality theorem. Now, according to similarity, AD is corresponding to AB. So AD upon AB will be equal to AE upon AC and also DE upon BC. This is similarity, what we did before, right? The corresponding sides are proportional. But for basic proportionality theorem, you will just write this AD upon
AD upon DB.
DB will be equal to AE upon
AEC.
BC. That's it. This is BPT, basic proportionality theorem. Okay. Are they same or are they different?
So here there is no need to prove that two triangles are similar.
Yes. Once, yeah, we don't need to show that the two triangles are similar. Like we don't need to write those three statements. Angle A is equal to angle A, angle D is equal to angle B. We don't need to write that. We can just write BPT. So it's understood that the two triangles are similar and we are using BPT, which is the next step. So the difference between both. Here we have AD upon the whole side AB. But for this, it's AD upon not the whole AB, just BB. Okay, so that's the difference between both these formulas. So when can we use BPTs? Whenever you have two sides parallel, like two bases parallel. So you can see that over here. See, D is parallel to BC. Here, we can't use it because they have not mentioned that the two sides are parallel. Is it mentioned? If it's mentioned, you can use, right? PQ is parallel to AB. So we can use BPT here. For BPT here, how it will be? Tell me the same theorem over here. CP upon PA is equal to CQ upon QB. Okay. Here, can we use that? See the question and see whether we can use that BPT.
Yes.
ABC is similar to AD. So they did not say that the sides are parallel, but they directly told you that the two triangles are similar. So if the two triangles are similar, yeah, then DE has to be parallel to BC. So we can use BPT here. See here, you have so many triangles.
Yes, I was having doubt in this question.
See, like this triangle, and this is a parallel line to this base. So these two triangles are similar, and we can apply BPT. That is one set. Now this side also, look at this triangle, and these two sides are parallel. So again, we can apply BPT for that side also. That these two triangles. You saw that, right, Aman? I mean, Ahmed.
Yes, sir.
So then I think you'll be able to solve after knowing that, no?
Yeah.
Yeah. So again, since there are too many triangles, there's like two sets of similar triangles. That means four triangles are there. So you can draw the required triangles separately and then apply similarity at figure it out which two triangles you're going to use. So here again, there are parallel sides. Okay. So which two triangles? Like if you look at this set of parallel sides here with a double arrow, so that's DAE, triangle DAE and triangle MBE. Okay, so those two triangles are similar. You saw that? So we can apply BPT for that. And any other? Do you see this also here? DCAE. So those two triangles, that's another set of triangles. So here again we have parallel sides. So we can use first vertically opposite angles are equal. Then angle D will be equal to angle E. What's the property?
Alternate interior.
Alternate interior. And angle C will be equal to angle A. So that also alternate interior angle. Yes, sir. So we have two sets of angles here. I mean, two sets of triangles. Right? Now, questions will be mostly based on sides. They'll give you sides. One side, they'll give find another side. Okay. Here, there are some prove that questions which mostly they don't come. So you'll have finding sides type of questions. Okay. Okay, we'll go to the next part of the chapter, relationship between areas of two triangles. Let's just rejoin the meeting. Okay, next there's a theorem that's regarding the area of two triangles that are similar. So let's take these two triangles itself that are similar. Okay, so we have written down the sides that are the corresponding sides that are proportional to each other. Okay? Now, if you want to find the relationship of their areas, that is, say, area of the small triangle AD upon the area of the big triangle, that is ABC, okay, they will be equal to any of the sides squared. So you can take any of the sides that are known, for example, AD upon AB, and square it. That will be the relationship between area of the triangles and their sides. Is that clear? So suppose we have AD, which is say 5, and say AB is 7. Okay. So we can apply in this and we can find the ratios of their areas. That is 5 square upon 7 square. So 25 upon 49 will be the ratio between their areas. Now say you have one of the areas. Then we can find the other area by this uh, equation. Okay. So that is this theorem. The areas of two similar triangles are proportional to the squares on their corresponding sides. Proportional. See what is proportional? The areas and the square of the sides are proportional to each other.
And it can be any side.
Any side. So you can take AE upon AC whole square or DE upon BC whole square. Because they're equal anyway. Right? So it can be any side. Okay, note this down. All right, look at this question here. Number 14, example 14. So what all we have here, angle B is 90 and this angle E over here is 90. Okay, so okay, let's just read it. AB is 12, AC is 15, so that's for the big triangle. D and E are points on AB and AC respectively, such that angle AED is 90 and DE is 3 centimeters. Calculate the area of triangle ABC and then the area of ADE. So let's draw both the triangles separately. This is ADE. Okay. First thing, to prove that the two triangles are similar. Okay, so how do we prove that the two triangles are similar? What?
Angle E is equal to angle B.
Okay,
Like
degrees. Then
angle A is equal to angle A, common angle.
angle A is equal to angle A, common angle. Right. So by AA test or AA condition, the two triangles are similar. Okay. Now the sides we have what all? AB is 12, AC is 15, DE is 3. Okay. So before doing anything, we should find which are the corresponding sides. Okay. So which are the corresponding sides now? Let's just mark A and A over here. Okay. So I'll tell one side, you tell me its corresponding side. AE upon which is the corresponding side here?
AB.
AE is corresponding to. So how do we figure this out? See, AE is between that known angle and the 90-degree. Here, which is that? The known angle and the
AB.
90. So AB. Okay, then DE upon
BC.
BC because it's between the 90 and the unknown. 90 and the unknown. BC. And last AD upon AC because that's the hypotenuse for both the triangles. Okay, so like this you're comparing. Now, what are the values that we have? What all do we have to find? So you can just take a pencil and write next to that what values we have. Now, AE, do we have AE? No, do we have to find AE? No, we don't have it. We don't. Okay. Next, AB. AB we have 12. Then DE, 3. BC, we don't have. AD, we don't have. AC, okay. Is there any side that is common? No side is repeating. There's no common side. And also there is, you need to have one set of values at least. See here we have one, we don't have the other. Here also we have only 3, we don't have this. Here also we have only 15, we don't have this. So we can't do anything. Like say we take these two values are missing. Say we take these two fractions, two values are missing. We need only one value to be missing. So we can't do anything with this as of now. What should we do? And what are they asking first of all? Calculate the area of ABC. Okay, area of
By
A. Yes,
Pythagoras theorem in triangle ABC, we can find BC.
yes, we can find BC using the Pythagoras theorem. Okay, so that is here BC square will be equal to AC square minus AB square. That is 15 square minus 12 square. How much is that? 225 minus 144. AP. So BC is equal to 9.
9 centimeter.
Okay, so we got BC now. Where is BC here? Here, BC. BC is 9.
We can find AD. AD or AD.
Yeah, if you use these two here, we can find AD because AD is the only missing value. And if you use these two fractions here, we can find AE. See, now we can find all the sides. Understand? After that, we'll find the area of ABC. ABC. ABC area we can find using half into base into height. Because we have the base, we have the height, we can find that. Now for this triangle here, I mean, if we have AE, we can find that, again, we can use half into base into height here also because DE and AE are perpendicular to each other. Base and height should be perpendicular to each other. Okay, but that's not how they want you to do it. They want you to use this formula here. So we compare both their areas equal to any of their sides, square it. Okay, we have all the sides. So you square any set of corresponding sides and you, so it's like this formula. You have this side, you have this side, you have one of the area, you can find the other area. So use that formula and find the missing area. Okay. All right, just complete this and there's one more question. This scale is there. Or anyway, you just understood this. Okay. We'll go to the next then. That is similarity as a size transformation. Okay, so here there is scaling. Scale means you have some shape that is small or some object that is small, and they're scaling it up to a bigger object. For example, a model of a ship to the real ship. So suppose, see this question. A model of a ship is made to a scale of 1 is to 200. That means what? 1 unit on the model will be equal to 200 units on the real ship. Like 1 centimeter on the model will be 200 centimeters on the real ship. Any unit you can put here, or 1 meter here is 200 meters there. Okay. So if the length of the model is 4 meter, calculate the length of the ship. Right. So here there's something called a K factor or scale factor. Sorry, scale factor. You take it as K, and K will be the scale, which is 1 upon 200. Okay. Once you have the scale, then you can find any of the known any value that you need. So there's the formula is like this: length of the model is K times the length of the ship. Length or any value of the model will be K times that same value of the bigger ship, the bigger uh, whatever it is. So for example, if you want to find height, what's the formula for height? Height of model is equal to K into height of ship. Okay. Or if you want to say any height, any value, distance. The formula is what? Distance of model is equal to K into distance of the actual shape, whatever it is, ship or car or whatever. Okay. Now, if you're comparing area, say area of model or area of the model is equal to dash into area of the bigger shape. Here you'll have to put K square. And if you're finding volume, if you're comparing volume of model to the volume of the bigger shape, here you have to put
Q.
K cube. Okay. So once you find K, if you have this value K, you can compare any value of the model to any value of the actual shape, actual object. Okay. If you're comparing a one-dimensional value like distance, height, length, breadth, then you'll use K. If you're comparing a two-dimensional value like area, you'll use K square. And if you're comparing a three-dimensional value like volume, you'll use K cube. This is clear for everyone? 1D, 2D, 3D. Okay. All right. So write down this. This is the whole part for this chapter, this exercise.
Sir, in similarity, I understood the first exercise and second exercise and third exercise.
This is the fourth, no? This K.
Yeah.
This is, in fact, this is the more easier one. Because you don't have to
Yes,
compare. Yeah, you just have to find K and then substitute in these formulas.
yes, I
Let's look at the seventh question here. A model of a ship is made to scale 1 is to 300. So what we have? We have K. Right there. What is that? Scale factor? Yeah, scale factor K is equal to 1 upon 300. The first question is, the length of the model of a ship is 2 meters. Calculate the length of the ship. See, they're comparing length. So, you know the formula. What's the
600.
formula you get? Length of the smaller model is equal to K into length of ship. Write the name of the object. Here, if it's ship, write ship. Okay. So we have K, we have the length of the model, we can find length of the ship. Okay, so that's for the first one. For the second one, the area of the deck, see area, two-dimensional. The area of the deck of the ship is this much. Calculate the area of deck of the model. So tell me the formula. Area of model is equal K into area of deck. Like we are mentioning which part. Okay, here also. Area of deck of model is equal to area of deck of ship. Right. What specifically we are calculating? Write that in your formula. And the third one, here we're comparing volume. Volume of the model is this. Calculate the volume of the ship. So again, here the formula will be what? Volume of model of ship is equal to K into K cube. So this is K square. K cube into volume of the actual ship. Okay. So either we'll have the left side value, we'll have to find the right, or we'll have the right side value, we have to find the left side value. Clear how to do this? Okay, just note down this and solve it and tell me the answer in a few minutes. Do it. With that, we're done with similarity.
The first one is 600.
Yeah. 600 what? Units is needed.
600 meter.
Yes.
Anna, can you please explain this again?
Which part? Like there are three formulas for one-dimensional, two-dimensional, and three-dimensional. Once you get K, you just substitute the value of K in the formula and you can find it. On the left side, you have the one-dimensional value of the model. On the right side, you have the one-dimensional value of the actual shape, actual object.
200 for second one. 200 meters. 200 meter.
So the first formula is for one-dimensional values like length, breadth, height, distance. Second formula is for two-dimensional value like area. And the third formula is for three-dimensional value, which is the volume. For one-dimensional, you have to use K. For two-dimensional, K square, and for three-dimensional, K cube.
And the first, the volume of the model, and then next is what? Volume of the ship.
Yeah.
Okay. So first the shape and then what?
Left side is the model, right side is the actual object.
Okay. What does K represent?
K is a scale factor. Like the scale. If they say scale is 1 is to 300, then 1 upon 300 is the K factor.
Okay. Thank you.
Yeah. So 300 square is 90,000. 4 zeros, 4 zeros. 18 upon 2 is 2. What you said, Amit, you said something else.
Yes, I got 2.
2. Okay, the last one, volume of the model is 6.5 meter square. So K cube is 1 upon 300 cube into, we have to find the volume of the ship. So volume of the ship will be 6.5. This 300 cube will go here into 300 into 300 into 300. So 3 threes are 9, 9 threes are 27. So that is 6.5 into 27 with 6 zeros.
So I'm getting up to 1755 and 5 zeros.
So okay, let me just use the calculators to finish it fast. 6.5 into 27.
I got 1755 with 5 zeros.
Yes, sir.
1755 with 1, 2, 3, 4, 5 zeros. Correct. This one unit is meter cube.
That's it.
All right. So we'll stop with this chapter. We have many more to do. Let's see what we can do with that next.